Okay, for this video we're going to look at two things. We're going to look at one, how to find the inverse of a 3 by 3, and then how to find the inverse of a 2 by 2 using the determinant, which I haven't showed you guys how to do yet, so this will be your introduction to it. Next chapter, or next section, we're going to spend more time with the determinant and what we can do with it. So let's start us out by first making our doubly augmented matrix. So we have a 1, 1, 6, negative 1, 0, negative 2, 0, negative 1, negative 3. Then we have the dotted line on the other side. That's where we put our identity matrix. So our identity matrix has all ones. It's simply in row echelon form, simplified row echelon form. And so our goal is to make this side the identity matrix using row operations, and then letting these numbers right here just go along for the ride. So whatever row operation we do, we still have to do it to these guys also. In the end, on this side, when this side is the identity matrix, this side will be our answer. So start with the first upper left hand number. That number is already positive 1, so we're going to leave it. I'm not going to have to do anything to this row right here to make it a positive 1. Actually, I should circle the whole row because you got to remember to do it to everything. So I'm going to use this first row to get rid of this, to make that one a 0, to make this a 6. So it's two separate row operations to do that at once, so I don't have to write as much. So the top row doesn't change, so I'm going to write negative 1, or I'm sorry, 1, negative 1, 0, 1, 0, 0. Let's space those out a little bit better. There's my dotted line. Okay. For the first one, I'm going to take the first row, multiply it by negative 1, and then I'm going to add that to row 2, and that's going to give us our new row 2. So 1 times negative 1 added to that would be 0. Negative 1 times that would be 1. Added to that we get 1. That would stay 0, so we add it to that, that stays negative 1. That positive 1 times negative 1 added to that would be a negative 1. And then this would be a 1, that would be a 0. These two stay the same because these two are zeros. Okay, the next one, to make this 6 a 0, I want to multiply row 1 again, use row 1, and then multiply it by negative 6. Then I'll add that to row 3, that'll give us our new row 3. So 1 times negative 6, and then added to that would be a 0. Negative 1 times negative 6 would be a positive 6. Positive 6 plus 2, negative 2, would be a I'm sorry, not negative, but a 4. Wow. And then for this one, this 0 does nothing, so this stays negative 3. And then on this side, we have that 1, it becomes a negative 6, added to 0 is a negative 6. 0 does nothing, so this one stays 0, and 0 does nothing, so this one stays 1. Alright, cool. So our first column is set up. It's ready to go. Now we just got to look at our next column. Our next column, we're not worried about these top numbers yet, so we're not worried about this negative 1, but we are worried about this 4 right here. How do we make that a 0? Lucky for us, this is already a 1, so we only have to do one row operation to make this a 0. So let's write our new matrix. I'll write the rows that aren't going to change. And then we dot, 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 dot. 1, 0, 0. And this one's going to be 0, 1, negative 1, negative 1, 1, 0. And then this last row is the one that's going to change. So let's write what that row is going to do. Let's see, we'll take the second row, and I'm going to pick the second row because if I were to pick the first row and try to use a negative 1 to eliminate the 4, that 1 is going to become a different number, and I'm going to add it to 0, and I don't want this to change from 0, so I'm using the second row to do this. So I'm going to multiply the second row by negative 4, and then add it to the third row to make that a 0. So we have negative 4 times row 2, and we're adding that to row 3, and that'll be our new row 3. So this will be 0, this will be 0. Negative 1 times negative 4 is positive 4, added to that is 1. Oh, that's kind of cool, because we needed a 1 right there anyways. And then negative 1 times negative 4 is going to be a positive 4, add that to negative 6, we're going to get negative 2. negative 4 times 1 added to the 0 is going to be a negative 4. And then nothing's going to happen with that last one, so we'll leave it at 1. Alright, cool. This side is almost in reduced row echelon form. It is in row echelon form right now because these are all 1s right here, and these are all 0s. Now we just need to make this a 0 and this a 0. Now to make this one a 0, I'm going to use this row right here, just because the 0 will not change that 1. This negative 1 is going to change that 0, and we do want a 0 there eventually, but in order to do this, we got to work our way from left to right, and so we got to take care of that number first. So let's write down the rows are not going to change. The top row is going to change. The second row doesn't change though. So we're going to write 0, 1, negative 1. On the other side we have negative 1, 1, and 0. And then the bottom row 0, 0, 1, negative 2, negative 4, and 1. Okay, I don't like that guy. Let's rewrite him. Alright, so for the top row, we're going to take the second row, multiply by nothing. Just take the second row and add it to the first row. And we should get a new row that we like. So this is going to be a 1. Just add those two numbers right there. That'll be a 0. Add those two numbers right there. That'll be a negative 1. And then we're going to add those two right there. That'll be a 0. That'll be a 1, and that'll be a 0. Alright, cool. The only two numbers we got to get rid of now are this negative 1 and this negative 1. And we can take row 3 and add it to both of those to get rid of those negative 1s, and then we would have the identity matrix right here, reduced row echelon form. Alright, so let's write the row that's not changing, which is only going to be the last row. So 0, 0, 0, 0, 1, negative 2, negative 4, and 1. For the top row, we're going to take row 3 and just add it to it. It'll be our new first row. And the second row, we're going to take row 3 and add that to row 2, and that'll be our new second row. Alright, so here we go. For the top one, it's going to be, let's see, 0 plus 1 is 1. 0 plus 0 is 0. 1 plus negative 1 is going to be 0. Over here we have negative 2 plus 0 is going to be negative 2. And let's see, negative 4 plus 1 is going to be negative 3. And then 1 plus 0 is 1. Second row, just adding these two together. So we get 0 first, then we get 1, then we get 0. Negative 2 plus negative 1 is going to be negative 3. Negative 4 plus 1 is going to be negative 3. And 1 plus 0 is going to be 1. Cool. We have our augmented matrix, our reduced row echelon form right there, which is also known as the identity matrix. And then we have our answer. Our answer is right here. So our answer is negative 2, negative 3, 1, negative 3, negative 3, 1, negative 2, negative 4, and 1. This is our inverse matrix, so we would write it like this: a to the negative 1. The negative 1 means inverse. Now, a really cool thing that you can do that I'm not going to do right now is you can take this matrix and multiply it to its inverse, and then you should get the identity matrix. And the identity matrix is a matrix with all the ones diagonal like that, with all the zeros, which is kind of neat. If you take this inverse matrix and multiply it to that, you should get this. Just make sure you use matrix multiplication. Excuse me, my nose is really bad right now. Alright, this video got too long, so I'm going to do the second part of the video in another video.